Hi class, today we are going to learn about section 2.1, Inductive Reasoning and Conjecture. This goes along with Standard 4, Reasoning and Conjecture. Our objective is going to be to make conjectures using inductive reasoning and find counterexamples. First, I want you to look at these four figures. We are going to find a pattern so that we can tell how many dots would be in the next picture. So let's start off by finding how many dots are in each picture. The first picture has 2, the second one has 6, the third one has 11, and the fourth one has 17. We need to find a pattern between these numbers so we can figure out how many dots the next one will have. So to go from 2 to 6, we add 4. To go from 6 to 11, we add 5. And to go from 11 to 17, we add 6. So you can see that each time we are just adding the next number. So to get to the final picture, we are going to need to add 7, which will give us 24 dots in the final picture. Go ahead and take a look at this set of numbers. I'm going to pause the video so you can try to find a pattern. What will be the next number in the series, and how do you know? But to get from 4 to 10, we're going to add 6. To get from 10 to 18, you're going to add 8. To get from 18 to 20, you add 10. And then to get from 28 to 40, you add 12. So the pattern is that you're adding the next even number each time. So we would add 14 to get to the next number, which would be 54. Because the difference is increasing by 2 each time, or you could say you're adding the next even number. So what were we just doing on that first slide? We were actually performing inductive reasoning. This is reasoning that uses a number of specific examples to arrive at a conclusion. A conjecture is a concluding statement reached using inductive reasoning. So that's an educated guess. So whenever we said how many dots were going to be in the next picture, that was a conjecture. Or when we said what the next number was going to be, that was a conjecture. We used the previous pictures to arrive at an educated guess of what would be the next one. So here are the steps for inductive reasoning. Look for a pattern, make a conjecture, and then check your conjecture. So look for a pattern, make an educated guess, check your guess to make sure it works. Here's our first example. Write a conjecture that describes the pattern, then use your conjecture to find the next item. So the movies times are 8:30, 9:45, 11, and 12:15. We need to find out how many time is between each of these. And you'll see that there's an hour and 15 minutes between each show. So my conjecture is that the next show will be at 1:30 because we're going to add an hour and 15 minutes again. So it says the next show time is an hour and 15 minutes greater than the previous show time. The next show time will be at 1:30. What conjecture can you make about the sum of two odd numbers? So this example is a little bit different because we don't have pictures or numbers to go off of. We are going to come up with our own examples. So remember, odd numbers are numbers like 1, 3, 5, 7, 9. Sum means to add. So we need to add two odd numbers together, and we're going to create a couple of examples and see if we see a pattern. So 3 plus 3 is 6, 9 plus 5 is 14, 1 plus 5 is 6, and 7 plus 3 is 10. I'm adding together odd numbers in each example. Now you want to look at the sum of each. Do you notice anything that these numbers have in common? All of the numbers are even, so the sum of two odd numbers is an even number. Let's try these two. I'm going to pause it so you can try them on your own. Alright, the first one, the sum of an odd number and an even number. So for example, 1 plus 2 equals 3, or 1 plus 4 equals 5. You're always going to get an odd number as an answer. The relationship between AB and EF if AB equals CD and CD equals EF. Well, if both of these are equal to the same segment, then that means that these are going to have to be equal. So you can say that AB is going to equal EF. You could also replace these with numbers to see if that would help you out. So if 2 is equal to 2, then this would be 2, which means that's 2. So that's just another way to go about it. That's it for today. See you in class.